Hi everybody, my name is Beatrice Starace, and with my colleague Francesco Ragazzini, we have developed, we have started developing this project that is more like a service design project rather than informatic or tech project. So me and Francesco both work as a tech specialist, but we have different backgrounds. We are social scientist and coordinator of educational services, and I am a designer and architect, and then we moved to we met each other at master degree program in media education and digital innovation, supervised by Professor Alessandro Ricci and Pier Cesare Rivoltella from University of Bologna. So today I will show you the stage of our project. This canvas show how we are working on this project. So first of all, the goal, we want to help children become fluent in computational thinking. And so we think that to do that, we have to give to the children and the kids as many chances as possible to practice computational skills. That's because, in our opinion, computational skills are important not only when you are coding, but also to solve real-life problems. So we start studying our users, and we have two users. The first one is the direct users that are teachers. And then, the first is students, and then teacher. That's because, for example, when you design a snack for kids, you have to design it sweet enough so the kids can enjoy, but also healthy enough because the parents has to buy it. So we have to combine two different users with two different needs. So the teachers that we want to help are not general teachers, general profile, but are teachers who are familiar with the constructionist approach, but struggle to apply in classroom, or teachers that are not familiar with the constructionalist approach. And it could sound funny, but in Italy, if you are an architect, you can teach computational science, or if you have a degree in natural science. So it's not common to know constructionist approach. What are the needs of this teacher? How to get students learning without controlling it and limiting it, how to experiment new tools and methodologies without feeling overwhelmed, and not feel limited by the constraints imposed by the school. For example, spaces, time, curricula, and grades. What about the students? The students that we consider are students who have not yet had the opportunity to try and experiment with coding, but also students who have had no the opportunity to experience coding from a constructionalist perspective. What are their needs? To create without fear of making mistakes and being judged for them, for the mistake that they could make, and to explore many different and diverse problem-solving strategies, and to recognize the value of what they've done. So our solution, our prototype, because we are less than 10% of our research, is a toolkit that helps teachers design and planning activities. Plus, this activity must be done in school during regular classes, not in the afternoon, club afternoon that many school has, based on the principle of constructionism. And since we are in school, there must be a tool that allows teachers, but also students themselves, to monitor, evaluate, and self-assess their learning. So to do this, we focus on student-centered design principle and facilitation technique. the school have constraints, and we want to avoid teacher-centered transmission, rigid prescriptive tasks, and the output focused over process. About the grade, we want a non-grade assessment, and that values errors visible to learners themselves and not just to teacher. And this is the learning through play experience that we took, that inspired us. So the unique value proposition is we want to design something that is a snap reimagined as a metacognitive playground that foster computational thinking beyond coding. Metacognition, what do we mean, is the act of thinking about your own thinking while you create and learning. So we could say that is a Lego serious play, but with snap blocks. How is the user journey? So we imagine 4 stages, but 2 are almost the same. The first one is what happened before the experience in the class. So design and plan. The teacher designed the learning environment, edit the CTA, and plan the activities. What are the CTA? The CTA are computational thinking assistant. Some of you tested one of these computational thinking assistant. We developed one for each computational thinking skill. So, for example, there is the Debugger, there is the Quarter, there is the Abstractor, there is the Iterator, and so on. And how do they work? Basically, it is like a conversation buddy. So when you have a task, it doesn't matter that if the task is inside Snap or outside Snap, since we have said that these competencies we can run in real life too. So it's like a buddy that guides you to the process of understanding what you are doing. In this case, we asked to, it's called Quarter because the exercise was that they built with Lego bricks a chair, and then the clips guide you in the process of taking inspiration. Now I run very, very fast, and this is one of the feedback that you gave to me, but I will come there later. This clip guides you in the process of edit your design and get inspiration from the design of other people, but then you have to quote the person that inspired you. So here you have a gallery of chair. When you choose the one that you like, you take a feature and you can, like this, and you can edit your model. For example, the results are, we encourage participants to share the results, their chairs that they edited, and then posted on a Padlet. So in this phase, that is during the process, the teacher has to prepare the classroom setting, observe students' behavior, and support students if needed. After that, the student facilitate sense-making session, and at the end, evaluate, assess students' learning process. The yellow sticky notes are the student point of view. This is a question mark because we want to know if the student can have a role also in this part, the part where teacher design, and we think it should have, but we are also figuring out. Then there is the second stage that the student code and interact with CTAs, and then sense making and self-assess. Key challenges for us. Stage 1, entering the process could be for a teacher, entering with in this mindset could be time consuming and energy consuming, and the teacher must continuously modify the CTA the CTI is a template, an empty template. The teacher has to put something, has to create the exercise. Stage 2, avoid making context. Some of you said that the CTI are too rigid, and so we have to figure out how can make them more flexible, which could become a counterproductive for the goal. Small exercises can not engage students as a project does. Conversational learning need to be fluent and natural, and we have to guarantee that UI and UX must work smoothly without glitches or friction. Stage 3, facilitation must be playful, and stage 4 is connected to school and cultural resistance to, for example, grade evaluation, and define clear and objective assessment criteria on evaluating a process and not a product. You know, it's not so easy evaluate a process, but it's more easy evaluate a product, a project. And here there are some benchmark. For example, we study lots of examples of what existing alternatives, so technical manuals, lesson plan, coding card, AI assistant, and design journals to monitor progress. And we took the positive and we try to experiment. And this is a cross benchmark that is inspiration outside the tech world. So, for example, that's why we started with Lego Serious Play, but also facilitation technique, liberating structure, design sprint, design thinking, learning to play. So, if this world is more what exists in a tech way, this one is about process way. Some of you asked me if we have run a test. Yes, we did. Here in black and white, you see the test that we have done before coming here. Not so many because we just started. And these are some feedback that the student gave to us. So we just tested the very small part of the second stage of our project. And they said that they felt less confused and distracted, but others said that the exercise was good at the end, but boring after a while. And others said that feel confident about making mistakes since there's no one watching me, and lots of other feedback. And these are the feedback that yesterday you gave to us. And thank you very much, because now we're starting to have new ideas. For example, making a conversation history visible to teachers or to students in order to assess process. We are thinking about focusing only on teachers. So if this project is to help teachers to design, why not? If the student find the clips boring, we have to adapt to their feelings. And or discard the CTI and focus only on the stage 1, 3, and 4 of our process. And that's it. Thank you very much. I know that this project is very different from the one that you are used to host here, but for us that we come from another field of studies, pressure all that you have, all that you say to us. And for this reason, if you have a pleasure to share your feedbacks, your inspiration, your thought, it will be for us very, very helpful. Form link or board link if you want to add some inspiration. You can do it freely. Thank you very much.
We were wondering, or I was wondering, your lovely slide deck or space on Miro, are you going to share that also?
Yes.
Is that public for?
Board link is, yeah, I can share the link.
Okay,
but,
thank you. So yes. This short URL comes to the Miro. Thank you.
It's meant to be, because we want your feedback. We want really want.
Wonderful.
Thank you.